Okay, and welcome to week -2, BreakerBot's code lessons, code structure, and code flow. Okay, so first we're going to start off with describing what the packages are and how they organize our code. So basically, these are the packages if you don't remember, and they organize our code into different sections as opposed to having all our classes in different files. Okay, so the first package is frc.team5104. And so this contains 5 main files that you'll be editing a lot. And so the first one is robot.java, which is where the robot code starts, and you can turn on and off certain subsystems in here if you want to disable the climber, for example. Superstructure.java contains every single state of the robot. This could be the robot's mode, like idle, intaking, aiming, shooting, climbing, etc. Or it could be other variables like whether the robot's trying to shoot low or high, or whether the paneler is trying to do rotation or position. Controls.java is a giant list of every single button and axis that is used on the robot. So everything from the shooting button to the joystick that controls the driving. Okay, ports.java. This is a giant list, kind of like controls, except it's a list of every single CAN ID and sensor port and things like that that are used on the robot. Constants.java. Every single constant, so variables that change that are specific to a subsystem will remain in their subsystems, but constants like PID values, motor speeds, etc., those are all inside this file. So it'll be intake intake speed. That could be a constant, and that specifies how fast the intake motor spins during intake mode. And it's nice to have them all in one file. It's super easy to read what value it is, and also if you're changing them, it's just one file to be inside. Okay, the auto package. So we have the main auto package, which is files that help run the autonomous, and then there's also two sub packages inside auto. So auto.actions is every single action that would be in a path. So an action could be intake, shoot, drive this trajectory, stop intaking, stop driving, things like that. And then we have paths, and a path is something that you would run during auto mode that would take up the entire time, and it's a sequence of actions that are run. So a path could be drive here, intake, drive back here, shoot, like something like that, and that would be the entire path. Now we have subsystems, and I'm not going to cover it in detail. We'll be covering that next week. But basically, it's just one file for each subsystem, and they handle the whole subsystem with motors and everything. Okay, teleop. This is so I'll go back here for a second. So what happens in auto is I'll cover this more in detail with the code flow after the packages, but basically it'll call the action will tell the superstructure go into intake when it's the intake if it's the intake action, and then the subsystem will be like, okay, I'm supposed to be an intake, and it'll handle that. Now for teleop, what it does is instead of having a path, it just has a teleop controller. So for example, we have superstructure controller, and what that does is literally if idle button pressed, tell the superstructure to idle. If shoot button pressed, tell the superstructure to shoot. Things like that. And we also have a drive controller, which is it reads the values from the axes on the controller, and it just tells the drive system how fast to spin the motors. Okay, we have the util package, which has it also has some sub packages, but I'll talk about that later. It's basically a bunch of utility files that could be used in writing subsystems or writing other files, and I'll cover a few. There's probably like 20 files or so, but these are the main useful ones. Console.java, this file handles the function you might have seen us use, and it's console.log, and there's also like console.error and a bunch of other things. Basically, what this allows us to do is instead of using the system.out.println function, we can use the const.log function. And the reason we use that is we can first, everything you print, we can add to a giant string, which then we can save as a log file to the robot, which we can read later. So if we had a code error in a match, we can go back and find the log file from that match and figure out if we can fix anything from the print statements. We can also print out what time that print statement was, or what time that print statement was called, and we can print out what subsystem it came from, just so it helps us debug a little bit better. Breaker bunch of useful math functions. One of them, it'll overflow an angle between 0 and 360. We use this on our turret, so that if you turn more than 360, it'll overflow and the turret will rotate and keep centered. And a couple others like clamp, which, for example, if I want to keep a number between 0 and 4, if it's greater than 4, it'll just set it to 4. If it's less than 0, it'll set it to 0. Pretty simple. We have Xbox controller.java, so WPIlib, they have their own Xbox controller class, but we wrote this file, and it's pretty similar, but a little bit different. Basically, what we can do is we can save button variables and axis variables inside that controls.java file, and that's super useful because it's super easy to read and figure out what the controls are and also change them instead of having inside a subsystem a function call and having to change all those calls, which gets kind of messy. Moving average, or it might be called a running average if you're somewhere else. Basically, what it does is you feed it a bunch of like double, integer, or even Boolean values, and it'll average them over the last n loops. So, for example, if I have some sensor data that's super jumpy, I'll plug it in to the moving average class, and I'll say average over the last 10 loops. That's a bit much, but whatever. And it'll basically smooth out all that sensor data. So one way to use this is we have a like a photoelectric sensor, like one that'll be true or false, whether it has something in front of it. We can average out those values. So if there's a electrical issue and it just ticks true for a second, we can just average that value out and it won't ever be there. Latch Boolean, what this class does is you can specify how you want to use it, but usually we'll just have it in the everything, or in the, I guess it's everything mode. And what that does is it'll uh, tell you when a Boolean changes from true to false or false to true, but you can also run it in a mode where it only is, we call it rising edge, when it's only false to true, or falling edge, which is true to false. Then there's the subpackages util.managers and util.setup, and those are kind of the back end to the code base, and most of the time you can just ignore them. Okay. The next step is the code flow, how data and updates flow throughout the code base. So first I'll cover how input data goes from the controller to the subsystems during teleop. So first what happens is the drive controller is like, okay, I just got an update function. I'm going to read the axis values, my specified axis values from the controller, and then based on those values, I'm going to do some math, and I'm going to figure out the left and right motor speed and tell the drive subsystem to move that fast. Now, similarly, the superstructure controller, it'll mostly read button values, and it'll be like, okay, is my idle button pressed? And if so, tell the superstructure to go into idle, and later on, subsystems will read the superstructure, and they're like, oh, I should be in idle mode. And then they'll turn off their motors, or whatever they're supposed to do in idle. Okay, so in autonomous, it's a little bit different, but also kind of similar. How this works is it starts with auto manager, and what this does is it reads from a list of it has a bunch of paths it can run. You tell it, I want to run my 6-ball auto, and it reads the 6-ball auto, and the 6-ball auto is like, I want to first drive here, and so it'll call that drive trajectory action, and the drive trajectory action will be like, I want the drivetrain, it'll call the subsystem drivetrain. I want the drivetrain to move 100% on the left motor and 50% on the right motor, and it'll change obviously, over time, and that's how that works. And then maybe let's say it's a different action, so it finishes the drive trajectory action, and now it wants to go into the intake action. So the auto manager will call the intake action, and the intake action, all it does is it just tells the superstructure to go into intake, and then from there, kind of like last time, the subsystems later on will read from the superstructure. They're like, oh, I should be intaking, and the intake will spin up the motors, and the hopper will get ready to move balls throughout it, etc. Okay, so we talked about how the data flowed to the robot. Now we want to talk about how function and method calls transfer throughout the code base. So, like we talked about just recently, the auto manager handles all the input data in auto, and so how that gets updated is robot.java has a bunch of functions that get called all the time at 50 hertz or every 20 milliseconds. So it'll be like, okay, auto manager, I want you to update since we're in auto, or if it's in tally up, it'll call tally up controller manager. Um, and so auto manager goes off and does its stuff, but tally up controller manager, what it does is like, I have these three tally up controllers I have to update, and it'll loop through them and update all of them based on which ones you have selected. And that could also be in Subsystem Manager. And Subsystem Manager, it also has a list of subsystems, and then it'll call the corresponding subsystem that it's supposed to update. And also, superstructure gets updated, and there's not a whole lot here, but sometimes a state inside the superstructure might need to change over time or based on a subsystem state. So, for example, if the hopper's full, it should stop into intake mode and it should go into idle. Or if it's shooting and the hopper's empty, it should go into idle. Things like that. Okay, that is it for the theoretical part. I know I covered that pretty quickly, but I just want to briefly cover what the code looks like in Eclipse, just to give you a better understanding. Okay, okay. So here we have our infinite recharge project, and basically in here, so here's that first package I was talking about. So in the robot file, it's super simple. I'll just give you a brief rundown of what it does. It has some of these functions like tally up start, tally up loop, etc., and it'll call their corresponding stuff. So in main loop, it'll always call the subsystem manager and the Xbox controller and the superstructure and stuff like that. And you can also enable and disable subsystems by commenting them in and out. So this will not run no code on the robot. This will run the drivetrain and the intake and things like that. You can also enable the tally up controllers, but that's less necessary because if you disable a subsystem, it doesn't matter if the superstructure controller is enabled. Okay, now we have the superstructure, and it might look a little intimidating, but it's really not. Basically, it's made up of these things called enums, and all an enum is it's a variable. We're basically making it our own variable type, and the variable type will be like, okay, I can be one of these values. The mode can be idle, intake, aiming, shooting, climbing, paneling, panel deploying, etc. And this changes depending on the robot, obviously. And then here we instantiate a version of that enum. So we'll actually store the current robot mode, and the current mode is idle, and that will change, and we can read that from the subsystems. And that's the gist of the subsystem. I mean, there are some getters and setters to read from the superstructure, but not super crazy. One of these is if my mode is intaking and the hopper's full, stop. Stop intaking and tell the hopper is full. Not super crazy. Ports.java, probably one of the simplest classes. It's literally a list of most CAN IDs and some like Roborio ports and stuff like that about where stuff is. Also some pneumatics stuff. Not super crazy. Controls.java, pretty similar. What this is we have some complicated stuff right here, but you can ignore that mostly. the gist of it is we create a button object called shoot, and it's the button B, and it's on the operator and the driver's controller, and that's basically it. You can also specify if it's just on one controller and things like that. Okay, constant.java. This is basically any variable, or any variable that doesn't change is a constant. And so every single constant in the code base, except for a few, are saved here. So variables specific to a subsystem will stay in that subsystem, but constants specific to a subsystem will stay here. They'll have some system name underscore the variable, and it's all caps to specify that it's a constant. And so it's super nice when you're tuning the robot. You can have all the PID values here, or the intake motor speed and stuff like that, all in one file. Okay, that is the main package. I'll briefly cover the other packages. So this is a pretty simple one. This is the idle action. Basically all it is it initializes, says it's idling, says it's superstructure to idle, and then says that it's done. Super simple. Paths are made up of a sequence of actions. So intake, drive here, stop driving, shoot. Super simple. Subsystems. We'll cover that next time in next week. But again, you can see that each subsystem just has its own file that it uses to handle the entire subsystem, their motors and pneumatics and things like that. Okay, now we have the teleop package, and what this is some super simple classes. Actually, I'll ignore that one, but we'll have drive controller, and it looks kind of complicated. It's really not. Basically, it has a value called forward, and it subtracts the two triggers. Then it does some math stuff, and then tells the drive subsystem to use these values and calculate how fast the motor should be. Superstructure controller is also actually even simpler. It reads this button value for the idle button, and it says superstructure, or when this is pressed, when it changes from true or false to true, it'll be like superstructure. You're idle. Go to idle mode, and make sure to stop the flywheel and turn off the limelight and print out idling. Some of the stuff is more complicated. It's really might look more complicated, but it's really not. So the intake subsystem, when intake is pressed, if it's already intaking, stop until it's exiting intaking. Otherwise, if you're not intaking yet, go into intaking and print out that you're intaking. Okay, and that's the basic stuff. Here is the util file I was talking about. A lot of files in here. A bunch of them are actually super useful. So that you'll use in your code all the time, like console and breaker bath. A couple of them are less common. Um, yep, that's it. See you next week.